Yeah, our next speaker is Mr. Rick Fleeter. And Rick founded and served as CEO of the microsatellite company Aero-Astro from 1988 through 2008. He's managing partner of SpacePoint, and he's an associate adjunct professor of engineering at the Brown University and a visiting professor at La Sapienza in Rome, teaching design of space missions, platforms, and systems. And he will talk about the SpacePoint component database status and innovations after 2 years in operation. So it's your floor.
Okay, I'm partly going to talk about what we've been doing in the past year, 2 years to upgrade the system, and partly talk about what this thing is and what was our motivation to do it in the first place. Of the 5 of us, 4 of these people were students of mine in a year-long course I taught at the Space Agency in Italy, in Rome. And I'd say of the 5 of us, 2 of us are really just pure systems designers. That's really what I did. And 1 of us is a pure software developer for concurrent engineering systems. And then 1 is someplace in between. The other 2 are someplace in between that and just users of CHEF, of concurrent engineering facilities that they do during their normal jobs during the day. We all have other jobs, and we kind of started this as this would be really nice to have, and now it's becoming something that is tending to compete with what we're really supposed to be doing the rest of the time. So that's the makeup of SpacePoint. We're just a small company of 5 people, and we're 5 fairly overworked people. Though that's probably true of every person in this room, so I'm not looking for much sympathy in that department. This was my experience. When I was still working as an engineer, I also took on a part-time job teaching at Brown in Providence, Rhode Island, teaching aerospace systems design to graduating seniors. And what I noticed about these people, which had been me, but 30 years earlier or a little more, was that they think of engineering as mainly design, mainly analysis, and a little bit design, and they never think about what I call shopping, which is where do you find the actual components you're going to build this thing out of? That just doesn't enter into their mind ever. And yet, when I was working as an engineer, I first worked for TRW back when there was a TRW and Jet Propulsion Lab before that in the 80s. And before that, I was a volunteer building little satellites for AMSAT in the 70s. A third of your job is really finding these components, and that's if you're lucky and you're very good at finding them, because otherwise you spend almost all your time looking for the components, and the rest of the job is sort of like, yeah, we know how to do that analysis part, but we really need to find this star tracker that we can afford, that fits our power budget, that fits our mass budget, et cetera, et cetera. So one of my jobs teaching is to explain to people, okay, so it's really an experience I had twice. Running my company, you're very conscious of what it's costing you every hour that engineer is sitting flipping through catalogs, calling up on the telephone, searching Google. I mean, if you go and search Google for magnetic torque coils, you find them eventually. You find them. I worked in microsatellites. If you type in microsatellites, you find out that there's a biological use for microsatellites, which are little entities which float around in your blood. And like the 15th entry has to do with things that are orbiting the Earth or other places. So it's a very inefficient process. And this is what both of my jobs taught me, that we need to do something to improve shopping. So the lessons learned at 40 years, a little bit of an exaggeration, but it was 10 times 4, and we've been running SpacePoint about 4 years. I think I started searching for components about 40 years, about 1974 when I started volunteering to MSAT. It's, like I said, not very efficient to use Google, nor to have your office filled with catalogs, nor to get on the telephone. And there's what we discovered, what we were talking about at lunch, is that you run into, innocently wanting to create a database, you run into all these interesting problems which you didn't anticipate. The most obvious one being that data in your database are like data in your satellite. Sooner or later, some cosmic ray is going to hit that data and change it, and you better find it before it changes so much of it that you can't reconstruct what you had before. And what happens to a database, the equivalent of cosmic rays, is that the vendors change their web addresses, they discontinue a component and start a new component that's called B, and the data sheet is at a different site, and they just stop making things, and of course new things come on the market, and then customers call you and say, gee Rick, we found this and how come it's not in the database? So you're just constantly becoming paranoid. So you have to scrub the entire database about every 6 months to every year, which is not very pleasant work because you have to go to every entry and see if that link is still alive, see if it's still accurate. What I found about when I first tried to sell this system to my boss at the space agency in Italy, he was like, well, we already have this, ESA already has this. But in a way they do and in a way they don't. And companies have their own databases, but they tend to be sectored. This is what my company used in the past, but not global to the whole earth. But there's also politics. If you're when I worked for JPL, if you pick one company and represent it in the database, you better be sure you've represented all the companies. Or you're constantly getting in trouble for representing one. It's easier to do this from the commercial side, and if you mess up, they can just yell at you and you can add their data, but there's no harm and no foul. Creating the database is fairly fun, but keeping it up, going through it and scrubbing it. And then, okay, one of the problems that we found in the concurrent engineering facility that we were using at the space agency and that I also use in my teaching situation in Rome is that instead of having a real radio, it will have a parameter with the mass of the radio changing with the number of watts of output. So then the person decides they want a 4-watt radio, but in reality there are no 4-watt radios. There are 2-watt radios and 10-watt radios, and if you need 4, you're going to buy a 10, and you're going to have that volume and that mass. And what happens in concurrent engineering, at least in our situation, is you end up having to redo the design once the actual shopping happens. So this is where we were. This is sort of our little timeline. We got started in 2010. We put the first system online in 2012. And another little detail is those 14,000 entries are not 14,000 components. About 4,000 of them are vendors. So that's cheating or what? No, it's not cheating because there are many components that are not on a data sheet. They're made to order according to your spec, and there's many vendors who don't have anything listed as a product, and yet they have all kinds of things flying in space. So we finally decided, okay, we're just going to have vendors. If you look for star trackers, you'll find star trackers, but you also find vendors who custom make star trackers to the specs of your mission. That original version was searchable with a browser like Firefox or like Safari. And all you got was that thing that's in my background, a big spreadsheet, and then you could narrow it down. I want just the ones that are not ITAR controlled. I want just the ones that are less than 1 kilogram. I want just the ones that consume less than 1 watt, and you gradually narrow down your search, and then you could download those to an Excel spreadsheet. So in 2013, we kind of moved into the modern world and created an interface so that while you're doing concurrent engineering, you can pluck components off the database and insert them with all of their component data into your design, which turned out to be the next one of our little problems, because as we were saying at lunch, some of the specs are in angstroms and some of them are in nanometers, and you have to sort that all out. So some real human being has to read the data sheet and translate everything into SI and whatever else to make it kind of a standard that you can rely on when you're inserting this data into your design. And this year, what the paper is actually about, I'm finally getting around to that in the last 5 minutes of my talk, is thanks to our interface with ESA, we were asked to change the interface from our sort of custom homemade web services interface to a more standardized JSON data exchange. And then we had a problem with space qualification level, that's our word, versus TRL, which is the ESA word and also the NASA word. So I made a slide on why we deviated from that standard. And the reason is that TRL, the first 5 levels of TRL, is nothing you want to use if you're building a satellite right now. Those are things that are either in the designer's mind, or they're working in a laboratory, or they're not working in a laboratory, but they'll probably be working next year. And for our target of people who are sitting in concurrent engineering trying to make a design that's then going to move on to phase B and so on, they want components that are either flown or are likely to fly or have been qualified on the ground in tests. So we created these 10 levels of qualification, based the first level being essentially level 6 of the TRL. So, okay, we like it, but the world didn't like it. So now we have a basically conversion. You can click a box and say, look, Rick, your SQL is very cute, but we need TRL because that's what my customer is specifying. And you'll get your answers in TRL, losing a little bit of the precision that we tried to add. But you can always flick the switch again and get the TRLs back, so it's not a very big constraint. So this is the basic map of the system. It started off at the top part where we had the database itself, a database interface that you could then search the database with, and then an interface to the user, which was the browser. And then we subsequently added the web services interface, which required us to develop sort of our own protocols. And now this year, the JSON interface, where we use the JSON protocols to reconstruct the table from the serial data that you get when you actually do a call. And that has really just happened. I mean, it's only really been implemented for a few components to test it, and then in the rest of this year, we're gonna do it. And this is sort of my wrap-up slide, which is, okay, we come to SECESA every year, and you know, why? In part because I'm really kind of probably the least experienced person in this room using concurrent engineering. So I partly come from my own education, but also we, you know, we try to get the word out. So I guess I have a commercial mission also. Though I have to say, our commercial motivation is more that it takes a certain amount of resources to keep scrubbing and keep finding and keep building the database. And if you let it go, it's like your garden. It just fills with weeds and it's useless, except, you know, that it's there. So we're trying to keep this thing in fairly good shape. It's become a work program for students in both countries to, you know, do the stuff that we need to do, to go out on the web, check all the links, go look for new things. And that brings me to sort of the third bullet here, which is the crowdsourcing element. I actually got the idea to build this database being a manic swimmer, and I was traveling forever for my aerospace job, and every time I'd land in some city, Kuala Lumpur, whatever it was, Colombo, Sri Lanka, the first thing I wanted to do was find a pool, and there's a swimmer's database online, and I was reliant on this thing. Finally, I called the guy and said, how did you come up with like tens of thousands of pools? And the guy said, well, we ourselves were traveling, and we collected a couple thousand pools. And then we started soliciting input from people like you who travel even more than we do. And now we've got, you know, some X tens of thousands of pools all around the world. And in a database, what are the operating hours? How much is it? Even how long is the pool? How wide are the lanes? What's the typical temperature of the pool? Is it inside or? You think it's going to be really simple, but these databases are really complicated. So we are now trying to make that transition and make it so that our users can tell us, hey, Rick, this component is in your database, and we make it at our company, or we did it here, or I used it on a previous mission, and start making your own entries. I think it's the only way that you can actually keep a database like this fairly complete. So that's our crowdsourcing initiative for 2015. And the completion of the JSON interface, and then frankly just to get more people to use. I mean, it's a lot of work to do this, and you like to see more than a handful of people using it. I have to say, when we get people to use it, particularly my students, they really like it because it's like solves an enormous problem for them. But regular designers who are working in companies, even many of them, are not using concurrent engineering, and they just use the browser and come in, you know, using their browser, and it's still a big time saver just to use it like that. So that's my talk. Thank you very much.
Thank you, Rick, for the presentation. Maybe a quick idea for a discussion. I understand the novelty is mainly the JSON and web service technology you're using now. Quickly, show hands who's using JSON and in the projects, web services. Okay, that's good feedback. Thank you. And other questions?
Just a clarification, Rick. I know that you are ahead of time, but SECESA 2015, we are not planning to do it. Or is 2016 or 2014? But
you know, one of the guys in the company said there won't be one in 2016. I said, yeah, but there was one in 2013.
No, it was.
What was in 2013?
It's always even numbers, so...
Right, but there was some event in 2013.
Is that an invitation that we have to make it also next year? I take it.
Anyone else?
If you let external sources input in, we've built decision support systems in the past, and giving the input to salespeople from companies for a component, sometimes their specification isn't as robust as you might want it as a design engineer. So you're going to have to think about the governance side of that as well.
Yeah, and I was asked, I think at lunch or earlier today, what do we do to quality check the data? And it's not like we're buying all these components and trying them out like consumer reports or something like that. So we're really trusting the data. If we have it there, it's because it's in open literature. It's either in a brochure, it's on their website or something like that, but we don't, warranty that it's really.
We see in the automotive industry, material specifications from companies, and then none of the autos, they don't believe them, so they want to test them out themselves.
Hi, thank you for this interesting talk. I was just wondering, also dealing from time to time with tables like this, at which point in time do you enter your new entry? When you have, let's say, all of these columns to be filled, or if you have only like 30% of the information?
And as soon as we find it, we enter it. And the database will accommodate blanks. So we just leave blank those ones that are not typically earlier stage components you don't have all the data for. So we put it in anyway, because if it's really valuable to you, the user might do that research and track it down even further. So we figure it's better to have it in there and have it be missing the data than to leave it out until it's complete, because many of them are never, there's always something that's missing from every one. The database is a little bit overly wide, so that sometimes some manufacturers provide a certain type of data about their product that another one doesn't even provide. So we have the superset of all of them. So most of the columns, I would say, don't have every single column filled in.
Thanks.
Hi, is the database just focusing on space segment components, or do you also consider ground segment components as well?
Right now we've talked about that because we got started as satellite system designers. So that's sort of another chapter that we haven't started yet. And it's really not all space systems because we don't really worry about rockets. It's really satellite space platforms and then observing equipment, telescopes and things like that, payloads and platforms. And I should say, adding to that, we don't call a component a resistor. A component is a subsystem that you would buy off the shelf. The smallest, simplest component might be like a magnetic torque coil, which is really not much to it, or a damping rod. Yeah, there are damping rods, even though a damping rod is really just a piece of metal. But there are not resistors, capacitors, plugs, and connectors, and that sort of thing.
How do you account for heritage? For example, MSP 430 is not space qualified, but a lot of people actually flying it.
Yeah, but I mean, that works into that's why we created the SQLs, to say, has it actually just been tested on the ground and qualified through ground testing, or has it actually flown? And one of the interesting things that you find nowadays in the CubeSat world is components that have flown that have never been tested. They have no test data at all, no formal test. So we wanted to include all those various categories. So there are many things in there that have been tested but not been flown. But that's up to you if you want to.
Some more questions? Okay, thank you very much.